All right. Good day, everyone. Um, Welcome to this exciting episode of chemistry lessons with the analogous. And I'm going to be looking at a very simple topic, a very curious aspect to beginner chemistry, or to those of us just coming into organic chemistry, which will be a Iupac nomenclature. So I'm going to go very diverse, very deep, and I'll be looking at nomenclature. I did the first video on nomenclature, which was all about the trivial nomenclature. So in this video, I'm going to look at the Iupac nomenclature and specifically the Iupac nomenclature. So quickly, for Iupac nomenclature, how do you name organic compounds? They say you knew in chemistry that have set aside some certain rules we should take when naming organic, or we should follow to guide us when naming organic chemistry. This union is the governing body of chemistry, and it's termed IUPAC, okay? And IUPAC stands for the International Union of Pure and Applied Chemistry. Okay, IUPAC have some certain rules to name organic compounds, and I'm going to follow them in no particular order. In no particular order, I repeat, in no particular order. So these are not the orders given, the sit down principle given by IUPAC, but in no particular order. So I'm going to use this part of the board. So first, to name organic compound, the first thing we have to do is to decide the longest continuous chain. So you're going to decide longest continuous, the longest continuous carbon chain. So we're going to first decide that. Now, so I'm going to give a very simple compound. So for those of us, so we can quickly get it. So I have this. So I have Cl, I have let's say H, okay, have H, I have Cl, okay, let's say H, I have CH3, I have H, I have H. So let's quickly first decide that first. So if you watch very well, this compound on the board is quite simple but interesting. Okay, now for this compound, it's quite quite simple. But let's follow the rule first. The first rule. First rule says, now since organic chemistry, by then you must have heard that organic chemistry central elements we're talking about is carbon. So carbon skeleton makes up the basic structure, or the central of the center of discourse, or the center of focus in organic chemistry. So if you check very well, if you look at carbon, if you see this, if you can, okay, this is chlorine. Now if you check very well, um, there are four carbons here. So this is chlorine. Now I have to decide the longest continuous carbon chain. When I mean longest continuous, it should not be having C and there's a Cl in between and there's another C. Let's say peradventure this kind of a scenario can occur. Or let's say let me look for a brief scenario. Yes, I'm going to come to organic compounds like this. So though there are four carbons here, only two are continuous. So they should continue. So if you check, the longest continuous carbon chain here should be 1, 2, 3, 4. Those are the longest continuous carbon chain in this compound. So how many isomers, pardon me, we have gone to isomerism, that's another different aspect. So therefore, so how many carbon is continuous here? 4 carbon continuous. So when we decide the longest continuous carbon chain, the first thing is to first decide the longest continuous carbon chain. Decide the longest continuous carbon chain. Decide the longest continuous carbon chain. We have decided that, and there are 4 carbons. So I'm changing my writing tool. Okay, there are 4 carbon. Okay, yes, decide the longest continuous carbon chain. There are 4 carbon. Next, what we have to do is to actually, second thing we have to do is to actually decide the parent suffix. This is my own method. Yeah, this is my own method where I follow the Iupac rules. So what we normally do next is to um, determine, so I'll put it like this, determine the parent name prefix. So I'm going to use the parent name prefix and give the parent name. Give the parent name, pardon, and give the parent name and give the parent name, with the functional group, with the functional group, with the with the functional group. Okay, now quickly, so with the functional group. So quickly, this first, I would like to also add in number one is that when you are determining the longest continuous carbon chain, determine the longest continuous carbon chain with, or let me just say with, let me use the word carry. Determine the longest continuous carbon chain carrying carrying the functional group. Carrying the functional group. Determine the longest continuous carbon chain carrying the functional group. Now, this particular compound on the board is an alkane. There are no particular functional group in an alkane. So alkanes don't have functional group. They are all single bonded compounds. They don't have a particular functional group. So that's why I'm not curious about the functional group. So when we get to other compounds, I'll show you their functional group, like the double bonds, the triple bonds, the OH, and so on and so forth. So now, so decide the longest continuous carbon chain carrying the functional group. That's the first thing. Second thing you have to do is to determine the parent name and give the parent name, what's it called? Determine the parent name prefix and give the parent name with the functional group. So what do we mean? So let's quickly apply that here. So quickly. So very, very fast. We have 1, 2, 3, 4. So we have 4 carbon alkanes. So for a 4 carbon alkanes, 4 carbon, actually this is an alkane because there's no functional group. So organic compounds without functional group are alkanes. So for a 4 carbon like this, the parent name is going to be, or the parent prefix is going to be a boot. Okay, so when the longest chain is 1 carbon, so I should have met as the parent prefix. When it is 2 carbon, the parent prefix is et. When it is 3 carbon, the parent prefix is prop. When it is 4 carbon, the parent prefix is boot. 5 carbon, the parent prefix is pent. 6 carbon, the parent prefix is eggs. 7 carbon, the parent prefix is eth. Now, 8 carbon, so 8 carbon, the parent prefix is oct. 9 carbon, the parent prefix for the parent name prefix is going to be none. So 10 carbon, the parent name prefix is going to be deck. For 11 carbon, we're going to have on deck. Okay, on deck. So for 12 carbon, we're going to have do deck. So those are the special ones. So from 13 carbon, we have tri-deck. 14 carbon, we have tetra-deck, and so on and so forth. So the parent name prefix is going to be boot. First, the first thing I have to do is to determine the parent name prefix. And what I have to do again is to give the parent name with the functional group. So the prefix is from the number of carbon first. So there are 4 continuous chain. The longest continuous chain is 4. So parent name prefix is boot. So what functional group is there? Since there's no functional group, it's decided to be an alkane. So it becomes butane. So the parent name of this compound is butane. But which butane are we working with? Which butane are we working with? So what are the other things attached to this butane? That brings us to root 3. So root 3, this is it. This is root 3. So we might have up to 6 or 7 rows. So for root 3, we determine substituent. What do we do? We determine substituent. Substituent. So we determine substituents. So what is the substituents? Or what are the substituents? Substituents are those particular group or are those group that are bonded to the longest continuous carbon chain. Those unique group bonded to the longest continuous carbon chain, but are not part of the longest continuous carbon chain. So substituent can be like this. So let me just use from some substituent can be CH3. When we have CH3, they are alkyls. They are alkyls. So CH3 is an alkyl. So this is methyl. I'll be doing for simple chemistry. So this is methyl. Okay. So this is methyl. So I can have C2H5. So this is ethyl. So common substituent. I can have for chloro. I can have for chloro also. Okay. I have Cl2. Cl, pardon. This is chloro. I have B arrow. This is bromo. So these are common substituents. Oxygen can also be a substituent in some cases. We call it oxy. Yeah. So sulfur can be a substituent. We call it thio. Yeah. So these are some common substituents you can come across. And on this compound, hydrogen is not a substituent, obviously. Hydrogen is not a substituent. They are what I call them. They are common homoatoms, or like where is the word homoatoms? They are in organic chemistry. In as much as I was studying carbon, the major element associated with carbon is hydrogen. So quickly, the only substituent here should be chlorine. So you determine the substituent first. So the third thing you have to do is to determine the substituent. So what's the first thing you have? The first thing you have to do now, because our Iupac nomenclature is an ordered system. So these are the substituents you can have. So if you are learning very fast, you should write them because I might clean them now. Okay, what is the fourth rule? The fourth rule, you number substituents. Just check this out. Number substituents. Number substituents. Number substituents. You have, this is very, very important. Number substituents with shortest shortest possible shortest possible length to functional group. The shortest possible length to functional group. Now, there's a part of this rule I will not have to write because of my limited amount of space I have here on the board. So there's a part of this rule I'm not going to write. Now, for compounds that don't have functional group, you number substituents according to the shortest length or shortest possible sum. So added to rule 4, for compounds that don't have functional group, like the alkanes, you number their substituents according to their shortest possible length from either side. I'm going to do one now. Or you number the substituents according to their smallest possible sum. On rule 4, remember I said smallest possible sum. When there's no functional group, you number substituents according to the the smallest possible sum of those substituents. So I'm going to check from the left, you add it up. Check from the right, you add it up. The smallest sum, you choose the side to use. We are going to illustrate. But once more, let's just number the substituents like this. Now, the substituent here is chlorine, and it has no functional group. Because it has no functional group, so the substituent is chlorine, it has no functional group. So what do we have to do? There's no functional group in this compound. Okay, so we have to take the shortest possible length from any of the side. So what do I mean? So if I come from here, 1, 2, chlorine is 2. If I come from here, chlorine is 1, 2, 3. So check from the right, 1, 2, 3. From the left, chlorine is 1, 2. So which one is shorter? We take from the left because it is shorter. So the name of the compound becomes 2-chlorobutane. 2-chlorobutane. The name of the solution the name of the compound become 2-chlorobutane. So what we are concerned about in naming organic compound are two things according to Iupac: the chain length, which will determine the parent name, and the substituent, which will be added to the complete name of the compound. So how we determine our substituents and how we determine our chain length all depend on the organic compound in question. They all depend on the organic compound in question. This last statement I said, I would like to add it to rule 5. So if you are watching from home, so just add this one to rule 5. So, okay. So for what's it called? So we're going to be like this. For compounds, without functional group, for compounds without functional group, for compound without functional group, number substituents substituent with shortest possible length or sum. So shortest possible length or sum. I would like to chip in a quick example. Let's chip in a quick example. So okay, we're gonna chip in another example. I want to see it. It's gonna be like this. Okay. These examples they're organic, coming from me directly. So I'm going to chip in some few examples. So if you have an example, if you have something for me to name on the comment section, you can add, or you have a name for me to draw the structure in the comment section. You are very free, and I'm going to answer you immediately. We respond to you immediately. It's an interactive class. I think I've responded to every other comment section prior to this video. I've responded to their messages and responded to their questions. So quickly, we have let's take a compound. Let's say we have CH3, we have CH2. So we're going to start like this now. We're going to have C. We're going to have OH. Okay. Let me put CH3 instead of OH first. So I have CH3. I have C. I have H up here, have CH3 here again, have H, I have F or BR, I have H, so we have CH2, we have CH3. Not very complex, but a little bit technical. Still an alkane, not complex, but a little bit technical. Okay, so to name this kind of compound is quite a little bit very simple. So I'm going to take this off, this parent substituent or parent prefix name off. Okay. Okay. So that's for that. Now, quite simple. Very, very quite simple. Now, through one, we decide the longest continuous carbon chain. How do we do it? Let's go. So if you check, because say 1, 2, 3, carbon that is continuing. Take note. 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5, 6. So obviously I should go with 1, 2, 3, 4, 5, 6, and 7. So the longest continuous carbon chain is 7. And from our information, there's no double bond, there's no triple bond, there's no OH, there's no COOH, there's no alkyl CHO functional group, there's no carbonyl functional group, C double bond O, and there's no special functional group. That means you should be leaving us with an alkane, because alkanes are the ones that have no peculiar functional group. And we have 7 longest continuous chain. So 7 longest continuous chain should be ept. So ept should be the 7 longest continuous chain, ept. And determining the parent prefix with the functional group. So the functional group, there's no functional group, but it says an alkane. So it becomes eptane. So that was on root 2. So we have eptane first. Eptane. Eptane is the parent name, but I will have to circle the longest continuous carbon chain in order to determine their how do I put it? That's to determine the substituent. So hydrogen can never be a substituent. I explain that. So my substituent should now be BRO, which is bromo, if you followed earlier, CH3, which is methyl, and another CH3, which is methyl. So we have 2 methyl and we have 1 bromo. So positioning is a very big factor. So that brings us to root 4 after determining the substituent. Root 3, we determine substituent. Root 4. Number the substituent with the shortest possible length in functional group. There's no functional group. We go to 5. For compounds without functional group, number the substituent with shortest, not short possible length. When did I write this? With shortest possible length or sum. So what do you mean? Is that we come here, okay? We look from the left because there's no functional group. We can number the substituent from the left and number from the right. If I number the substituent from the left, I should be having something like 1, 2, 3. So I should be having I should remember I had methyl. So The way you normally name methyl, we'll call it dimethyl. Okay, dimethyl. So I should have two methyl group, two methyl group. So I should have two methyl group already there. So having two methyl groups will make me two. That's a dimethyl. So let's check. Let's check the number. 1, 2, 3, 4. So 3, 4 from the left. So 3, 4. So from okay. Then we also have another substituent which is bromo. From the left, bromo is 1, 2, 3, 4, 5. Bromo is 5. So 3, 4 dimethyl, 5 bromo. Number from the left. You get this. So you take the sum. You obviously take the sum. What's the sum? 3 plus 4 plus 5. That should be 7 plus 5. That should be 12. God bless. So let's go from the right. Let's go from the right. So from the right, we should have 1, 2, 3. So we have 3 bromo. Okay. Bromo is now 3. Methyl is now 4, 5. So 4, 5. So 3, 4, 5. So if you check, so what will be the sum? So let's see the sum. The sum is going to be so I should have I think we should be having the same sum. We should be having the same sum, which is 3 plus 4 plus 5. 3 plus 4 plus 5, that gives us 12. That gives us 12. So if you were asked, now we have a dicey situation. Now the bromo and the alkyl or the substituent across both sides have the same sum. Something across both sides have the same sum. In this kind of case, what you have to do is to first arrange. So I'm going to arrange the name of the compound. So I'll arrange the compound first. The compound, I'm going to follow alphabetical order. So bromo will come first before methyl. So the name of the compound is bromo hyphen. There's a number, and we have dimethyl. Please follow my method. And we have heptane in this case. So now, how do you apply your name? Now, if we are to write it like this, let's assume, this is what I do. This is what I do, and you get it. Now, let's assume I have 5, 3, 4. And I assume another case, I have 3. Now I'm coming from the right. We have 3, 4, 5. Why am I going through this other step? Because the sum on both sides were the same. The sum on both sides were the same. So I'm now assuming if I have 5, 3, 4. Please, dimethyl will never come before bromo. When you are naming organic compounds in an Iupac nomenclature, the names are right, especially when when you are arranging names of the substituents, they are arranged alphabetically. So B before M, which is methyl. So, assuming I've arranged this alphabetically, 5, 3, 4, and 3, 4, 5. Because first of all, they are the same sum. So I'll now ask 5, 3, 4, and 3, 4, 5. Which of these numbers is smaller? Obviously, 3, 4, 5 will be smaller. That gives me the name. That lands me the name 3 bromo. Then I will have 4, 5 diameter. So I'm going to use alphabetical order now helps this right hand side. So alphabetical order helps the right hand side number to be more accurate than the other. So, but normally what we go through first is smallest sum. That is the rule. The rule says smallest sum. That is the rule. So these ones are extra. There are extra points for when the sums are equal. So when the sums are equal, we what's it called? We practicalize these simple ones. So that is the name of the organic compound. So 3-bromo 4,5-dimethyl heptane is more appropriate than saying 5-bromo 3,4-dimethyl heptane. So it's due to appropriability. That's why I will choose this one over the left-hand side sum. So that's why as when I gave the compound earlier, I said it is quite technical. It is quite a little bit technical. For those of us writing exam, these are the some types of naming they can use in train you off balance. It's quite simple, but if you watch the video, rewind, check, you get it. So now let's quickly move to another one. So quickly, no time to waste. Then let's go. So now I'm going to put a very first one for the first time that has a functional group. Then I'm going to do something on it. We'll do a little bit, something a little bit tricky. So I'm going to do, okay, I'm going to have CH3, CH2, CH2. I'm going to have on this place, I'm going to have a C, okay, it's going to be tricky, it will be tricky. So if you're watching this video, you will learn a lot, You learn a lot by watching this video. So I'll make it C, then I'm going to put CH3, I'm going to put CH3, so I'm going to put C, okay. So in this video, I'm also going to help us name carbon compounds via the skeleton. So I'm going to put CH, that's beautiful. So I'm going to put CH2, I'm going to put C that has a Cl, that has H, I'm going to put CH3. So, okay, and I'm going to adjust, I'm going to place my functional group somewhere here. So my functional group should be, okay, let me make it a double bond. So my functional group should be a double bond. All right. As I said earlier, these questions are unique to me, but they are compounds that can be easily named. So we have a compound on the board, an unsaturated compound. For those of us that will learn organic chemistry further. So our next video after this one for lessons is going to be an alkane. Okay, I'm going to do a video on flowering plants before that of the alkanes. Okay, but our next video basically on organic chemistry is going to be on alkanes. Then watch our short videos on daily benefits, on how we can live a healthier life. So I did currently working on a short on the benefit of exercise. Those of us that don't exercise regularly, you see why you need to take it upon yourself as an habit. So just subscribe to this channel and be informed of a lot of things. This is science. We're looking at science, strictly science here. So back to base. Now, I have this compound, sweet compound, and I want to name with my rules. These rules are summarized for some text. You see these rules as 10, some text you see as 7, but just put them. It works here. So now quickly, let's go. Now I have an organic compound this long. So first of all, the first thing I have to take is I have to decide the longest continuous carbon chain carrying functional group. That means I will decide it from here because it is here the functional group on this compound is a double bond. Double bond, triple bond, OH, COOH, they are functional groups. So I'm going to decide it from here. Now it is here I will start from. So if you decide from here, so I'm going to count, I'm going to say 1, 2, 3. I cannot say 4, 5, 6. Let's check. It must be the longest. 1, 2, 3, 4, 5, 6, 7. So which one do we pick? The one that is of the 7 chain. Yes. So if I should outline that out, this becomes my longest continuous carbon chain. Remember, anything not on the longest continuous carbon chain is now a substituent. So we have 2 substituents. This one I highlighted last is a little bit dangerous, quite dangerous, very dangerous. So we're going to quickly take it ourselves as a step down and just demystify it. Now quickly, the longest continuous carbon, first is determine the longest continuous carbon chain and carrying the functional group, which is done. 2, determine the parent name prefix and give the parent name. So the parent name is determined by the longest continuous carbon chain, but we have to determine the prefix. How many carbon does it have? 1, 2, 3, 4, 5, 6, 7. It has 7 carbons. So 7 carbons should be eth. If you are following, eth. Like an heptagon with 7 sides. Eth. Now, but does it have a functional group? Yes, the functional group is double bond. When double bond is your functional group, just follow this video. It's called an alkene. When triple bond is your functional group, it's called an alkyne. When we have OH as a functional group, we can call it an alkanol, or yes, normally alkanols, the O's, OL. So you can just say heptanol. If that's an alkene, you say heptinol. If that's an alkyne, heptynol. So many and so all those things. When we get to the individual organic compounds, we will see their names too. So we have ept. So ept is an alkene. So we say eptene. But when for functional groups like this, any functional group, you also have to determine the number. When you don't put the number, it's when the functional group is on the first carbon. And in this case, clearly it is seen that the functional group is on 1, 2. And when you are numbering the functional group, you number the functional group with the shortest possible length. That means I don't number functional group like this: 1, 2, 3, 4, 5, or rather 1, 2, 3, 4, 5. I'll say the functional group is 5 in. No, the functional group is shortest possible length: 1, 2. So that's F2 in. Beautiful. F2 in is the parent name. F is the parent name prefix. So F2 in is the parent name. That is the owner of the compound. That aside, after getting F2 in, after doing F2 in, I'm going to quickly look at my substituents. My substituents are two. First one is very simple. The first substituent I have is chloro. But this substituent is technical, so that's for sale. That substituent, now, this substituent, if you observe very well, the substituent is like, if let me explain a little bit of some stuff. So you see, now, if the substituent would have been like this, how would you substitute? So we had a lot of chains to the left, to the right, and the substituent was just like this. You say it is metal. If the substituent was like this, I know I wrote it earlier. I wrote it earlier as C2H5. If it was like this, CH2CH3, I wrote it as C2H5. Now, this time we're going to call it ethyl. Now, if the substituent was like, let's add an extra carbon. Let's say I put 2 here and I put CH3. What should be that? It should have been ethyl or propyl. But now, I have a propyl, for instance. I have a propyl as a substituent. Now, this substituent is like carrying another substituent. So it's not a complete propyl. It's a propyl, yes, as a substituent, but it is carrying a methyl group. So this kind of substituent will be called a 1' because it's a substituent. It's normally a substituent. It's not even part of the chain. This substituent should have a number too. This substitution, and we number because there's functional group, we number from functional group. So from functional group N, that's what we number from. So this is 1, this is 2, this is 3, this is 4. So normally this group would have been 4 already. 4, this is 5. We already have, sorry, 5, this is 6. This is 7. We already have carbon 1. We cannot say 1 again because on the substituent is on 1. Why is it on 1? Because this is where the substituent is coming from. This is where we are. This is the reason why we are recognizing as a substituent. This is the first carbon attached to the parent. So this should be 1, this should be 2, this should be 3. So it is on 1 on the substituent. But which of the 1 on the substituent is on? We don't just call it 1, we say 1'. So if I were to name it, we say 1' methyl. 1' methyl. What is then now the normal substituent? Propyl. 1' methyl propyl. Now for some conventional textbooks, they will take this thing as isobutyl. So some conventional textbooks take it as isobutyl. Yeah, but isobutyl to me is not a Iupac. The word iso, if you check our previous video, they are usually trivial nomenclatures. Some of them are derived nomenclatures. No, they are not. So the proper name, so in case your exam carry isobutyl, no problem. So the proper name is 1-methyl propyl. That's Iupac. Now, check for this. Let's quickly look at this substituent. Now, if we check this substituent, now I will quickly explain this substituent here. Clean isobutyl. Okay. Observe this. Pause it. Look at it. Take the video back. Watch it. It's tricky. Now, let's take for instance another one like this. So let's say this particular example. Now we have a C. Okay. I hope I'm not missing something. So there's supposed to be H here, pardon. So CH2CH3. So which substituent would have been this? This is 2 carbon alkyl. This substituent would have been becomes an ethyl. But ethyl along the line has a methyl group. So this one is ethyl. Yes, this was 4 ethyl. 4-ethyl, but it has a extra methyl group. So this extra methyl group is giving, so we have 4 as it is 4, it's 4. Now we have 1 prime. Yes, it's on carbon 4. Are you with me? The substituent is on carbon 4. So 4, okay, or let me just name the substituent first. So let me name the substituent first. So let me name the substituent first. I should have what's it called? I should name the substituent first. I should have 1 prime methyl, 1 prime methyl, then the main substituent is ethyl, 1 prime methyl ethyl. Now 1 prime methyl ethyl. Now, and it's on what position? On position 4. I said for some text they can call it methyl ethyl. That should be propyl. So some text, because 1 plus this should be like propyl. So many texts will not say isopropyl, 4 isopropyl. There's usually no prime in that. 4 isopropyl, then the alkane. It's quite dicey, but I like the silence in your room now. I like the silence. It's nice. I really like it. Oh, rewind, check. It will be fine. So quickly, so what will be the name of the compound? Alphabetical order. The substituent name is 1-methyl ethyl. So alphabetical order. I should give chloro is the prevalent alphabet. So it should be 6-chloro. So I should go with 6-chloro. 4. Check that out. 4 1 prime methyl, 4 1 prime methyl ethyl, ept 2-ene. I said I like the silence in your room. So in your wherever you're watching this video from, I love the silence. Yes, it's really giving me a lot of excitement right here. So that is how we treat such compound. This is how we treat such compound. I would really like to treat more examples, but I can't go beyond the length of this video. The video might become too long and extend to hours, and some people will not be able to watch it, so it becomes maybe boring for some. But I'll have to draw it here. I have to close it here. But when in subsequent lessons, I'll use other examples to show you the Iupac nomenclature of some organic compound. So until the next video, I remain the analogous. I will see you when I see you next. So for now, it's going to be a bye. Have a blessed day. Have a nice moment ahead. God bless.